So I'm delighted to introduce my friend, Dr. Peter Turkeltaub. And Peter is an associate professor in the departments of neurology and rehab medicine, and the director of the Cognitive Recovery Lab and medical director of the Center for Aphasia Research and Rehab at Georgetown, and the director of the Aphasia Clinic at MedStar National Rehab Hospital. He received his MD PhD from Georgetown, and he did a neurology residency and cogneurology fellowship at Penn, which is how we know each other. And he worked, were you actually in Branch's lab when you did that fellowship, or Roy's?
Yeah,
Yeah,
yeah, I was in Branch's lab.
yeah.
Yeah.
So his work focuses on the organization of language, and as well as enhancing recovery from post-stroke aphasia, alexia, and dyslexia, primary progressive aphasia, and autism. He invented activation likelihood estimation, ALE, which, as many of you know, is a meta-analysis technique that's become the most widely used meta-analysis technique in neuroimaging community. In 27, I'm sure you've won more prizes than this, but I happen to know about in 2017, Peter won the Norman Geschwin Prize in Behavioral Neurology, awarded by the American Academy of Neurology, which is a very high honor, a well-deserved honor. And one of the interesting things I learned about you, Peter, is that you are a featured neurologist in a children's book about aphasia. So what's the name of the book? Do you remember?
Oh gosh, it's
I
called.
think it's like talking about aphasia or
Now,
something like that.
now I understand aphasia. Yeah, yeah. I
Mm-hmm.
appear as a cartoon character in that book.
Oh, I have to check that out.
Dr. Turteltaub. Yeah.
That's cute. Okay, and today Peter's going to talk to us about inner speech and aphasia. Thank you, Peter.
Well, thank you. That's like the best introduction I've gotten in years. That was really nice. Thank you, Laurel. And it's really great to be here or there or wherever we all are with you. And it's nice to see so many familiar faces. Now, before I start, can I check, are you seeing the right thing on the screen, or are you?
Mm-hmm.
Okay, good. Okay.
Yes.
All right, so I'm going to talk about some work on inner speech in aphasia today. This is not our primary area of research. Most of my work is neuroimaging, and most of this work is behavioral. And I don't get to talk about this very often, so I'm really excited to tell you about it today. So most of this work was actually done by two graduate students in the lab. William Hayward on the left, he's an MD PhD student. And he's a neurology resident now. He's about to finish up and do a fellowship in Leo Cohen's lab at NIH. And then Mackenzie Fama, who I think many of you know, who is now an assistant professor of speech and hearing at GW. And so a lot of the slides that you're going to see are their slides, and I'm just talking for them. Okay, before I start, I have some disclosures. So we did have funding for this work from NIDCD. I also want to disclose that I am not at my home or in my lab. I'm at an undisclosed location in the Shenandoah Valley. So here is a picture out of the deck. It's no longer snowing here, but this was earlier in the week. So we have very nice views of the woods here. We have nice mountains nearby. These are my two kids on the right, and then their friend Tomas on the left. And if I act at all strangely during this talk, it's entirely because I've spent the week sleeping under this incredibly creepy painting, which is hanging over the bed, and it's giving me nightmares. So I want to leave this up for a second so you can see like the details of just how creepy this is. All right, so on to the talk. So today we're going to talk about aphasia. I think everybody here probably knows this, but aphasia is an acquired disturbance of language in which knowledge about the world is typically intact. And it's caused by any kind of dysfunction in the left hemisphere in adults, but stroke is the most common cause. And it is common. We think about 1 to 2 million people in the US have it, and we know that it's an important public health problem. It reduces independence and quality of life. So it's important that we understand this problem. Now, one of the universal deficits in aphasia is anomia, which is a problem with naming and word finding. And anomia, or naming, is a multi-step process. So you have to start with a concept or an idea in mind and pull together the conceptual information that you have about that idea. You need to identify a word in your mental dictionary and associate that with the sounds that go with the word, so the phonological representation. And then you need to convert that either abstract or maybe auditory representation into a motor plan for production through some additional steps. And so a problem in the sort of the first 4 boxes here is usually referred to as anomia. And then a problem at this last step we call apraxia of speech. So this is a problem with motor speech planning. Now, most people with apraxia of speech also have anomia, and for an individual person, when they make an individual error, it can often be very difficult to tell if the error is apraxic or phonological in origin. So for our purposes today, I'm gonna be a lumper here, and I'm gonna just call any problem with getting from an idea to a spoken word, I'm just gonna call that anomia, and I'll ask the speech therapists and the cognitive scientists to forgive me for that. Okay, so we're talking about a problem getting from ideas to words. And the big question that we're gonna ask today is, what does that feel like for people? And people with aphasia, if you spend any time with them, love to tell you about this. So they will volunteer a lot of information about what it feels like to them when they can't say a word that they want to say. You don't have to ask them, and they're very happy to tell you about it, but we do ask them in our lab. So I'm gonna show you a video of Mackenzie asking one of our participants. Oh shoot, I may have to change how I do my screen sharing. Here, I'm gonna play it and let me know if you can hear this.
Do you ever know what you want to say, but you can't say it out loud?
Yes.
Please describe that feeling.
My head is saying it, but my mouth not saying it at all.
Okay, did you get that? So she said, my head is saying it, but my mouth is not saying it at all. So people say lots of different things to describe what their anomia feels like. So the most common thing I think that we hear is, I know it, but I can't say it, something along these lines. And this is a sort of a general description of anomia. It's not particularly specific or informative. We think that the know it could mean a lot of different things. It could mean I know what the idea is, or I know what the word is, or I know what it sounds like. Now, we've all experienced this one. It's on the tip of my tongue. So this is a sense that you know something about the word. Maybe you know the first sound, or maybe you know the shape of the word or how long it is, but you can't quite get to the word in your head. But very often what people say is something more like what this woman said. So they'll say something like, I can say it in my head, or I can hear it in my head, or it sounds right in my head. And this is a pretty specific claim. Here they're saying that they have the word, they can hear it in their head, the word sounds right in their head, maybe they feel like they can say it in their head, but then they try to say it out loud and it comes out wrong, at least some of the time. So we've lumped these together. The first two may be slightly different, but we've lumped these together, and we're calling these an experience of successful inner speech. And so that's going to be abbreviated SIS throughout this talk. And you should just be aware that when I use this term, what I'm referring to is their subjective experience. We're not saying that we know for sure that their inner speech is successful, but they feel like it is. They feel like they know the sound of the word and they can hear it or say it inside their head. So our main research questions and our goal today is to address whether reports of successful inner speech are meaningful, and then what they mean. And then we're going to try to address who experiences successful inner speech. So what kinds of deficits and spared abilities are associated with this, this sense of successful inner speech, and a little bit about what parts of their brains may be affected by stroke that relate to this. So I'm going to back up for a second and give a little background on inner speech. So the term inner speech is used for a lot of different things, actually. One of the common uses of inner speech is self-talk or an inner dialogue, which uses mental imagery of a number of different types. So it's a sort of more abstract notion of inner speech. And I'm not really sure the word speech should apply here. It's not specifically about speech. It's about mental imagery. The sense that we're using inner speech is a more specific one. This is one of the definitions, an ability to develop an auditory articulatory image of speech without uttering a sound. So this is a little bit more more specific, and we think, more along the lines of what people mean when they say they can hear the word or say the word inside their head. There's actually been a lot of interest and work on inner speech through the years. So even in ancient Greece, there was some idea that thought and language were associated, and some discussion about inner speech. Formal research on it really didn't start until the 19th century. And the idea in the 19th century and the early 20th century was that inner speech is the basis of thought, and that it requires the same articulatory movements as overt speech, but just to a lesser degree. There's a lot of work linking inner speech to mental tasks, reasoning, working memory, reading, executive functions, and others. And there's a really long-standing debate about whether inner speech involves internal modeling of articulation. And I think, I would say the consensus here, if there is one, is that it can involve internal modeling of articulation, but in some task situations, it doesn't necessarily have to. That it can rely on either a more abstract phonological representation or an auditory image. And we're going to address that a lot today, which is why this is highlighted here. So in studies that look at inner speech, there's sort of two main approaches to measuring it. The first is a subjective measurement. So these are self-reports like the video of the woman that I showed you earlier. And then there's objective measures of inner speech, which usually take the form of silent phonological judgments, either on written words or pictures. So these are things like rhyme judgments or homophone judgments that are done silently inside the head. And the idea is that these are proxy measures where you have to have access to the sounds of words in order to make judgments about them in your heads. And so this is a figure on the right from a review paper that Mackenzie and I wrote, sort of addressing strengths and weaknesses and just attributes of these different approaches. They do have strengths and weaknesses, so you can imagine subjective approaches are subject to individual biases, and they require error monitoring. The objective approaches really only measure certain aspects of the words, and they require other functions like working memory. So our approach in general has been to get the subjective measurements and then try to get supporting objective data to address whether the subjective reports are meaningful and what they mean. Now, when we started this work, there really wasn't much out there on inner speech in aphasia. So there were a couple of studies using objective measures like silent rhyme and homophone judgments. And then Bree, who's here with us, published a couple more after we started this work that used the same silent rhyme and homophone judgments on written words. And overall, I would say that this work has supported the idea that people with aphasia can have spared inner speech despite having severe speech production deficits. So the finding here is that they're able to perform these silent phonological judgments even when their overt speech is really severely impaired. Now, there was only one study that we could find at the time of subjective measurements of inner speech. This was a study that Harold Goodglass and Edith Kaplan and others had done in the 70s, the year I was born actually, where they took a bunch of people with aphasia and of different diagnoses, and they had them name pictures. And when they were unable to name the pictures, they asked them if they had an idea of the word. And so they call this tip of the tongue, but the question was, do you have an idea of the word? And then they asked them how many syllables the word had and whether they could identify the first letter. And the finding here sort of corresponds with what a clinical intuition would be, this should look like. So people with conduction aphasia, these people have problems primarily in phonological output processing. They report the most tip of the tongue, and correspondingly, they know the most about the phonology of the words. People with anomic aphasia who have problems earlier in the processing stream, in the word retrieval, report the least tip of the tongue and have the least knowledge of the phonology of words. And people with Wernicke's aphasia who have unreliable monitoring report a lot of the tip of the tongue, but they're not able to answer the questions about the sounds of the words. Okay. So we were a little surprised that there wasn't more research on this because when we started to think about doing this work, we thought it was really interesting and potentially important. So I always like to pause when there's less research in an area than I think there should be to make sure that it actually is a question that's worth asking. So let's talk about the implications of this type of work. So I think from a scientific perspective, studying people with aphasia gives an opportunity to identify dissociations between inner speech and overt speech, which is pretty rare in the general population. And the fact that they have disruptions at different levels of processing gives us the potential to identify mental and neural processes that are required for inner speech. So from a scientific perspective, that's largely what we're interested in. And then from a clinical perspective, there's a bunch of potential implications as well. So people with aphasia talk about their experience of anomia all the time. And I think doing some research on what they're telling us about their inner speech can provide some validation of their self-perceived deficits. It'll also help us potentially understand the nature of their deficits better. And then potentially, if this works out, maybe there might be some implications for how we deliver treatment to them. So I'm going to jump ahead a little bit to talk about this clinical significance, just to show you one piece of data to support the idea that these sort of subjective reports of inner speech might have clinical significance. So one of the first things that we did when we started to get into this area was we took 2 participants in a study that Rhonda Friedman was doing, and she was doing an anomia treatment study. And she had already done multiple baselining on these participants. So she'd shown them 300 naming items on 3 different days and established a set of items that that these people couldn't name on all 3 days. So we know that these people can't get to the words of, for these pictures reliably. And then they were going to do a paired associate naming treatment to try to improve naming of these items. So before they did the treatment, we showed them the treatment items again, so the words that they couldn't name across 3 days, and we asked them to name them inside their heads and just tell us which ones they felt like they could say inside their heads, even though we know they can't say them aloud. And then we looked to see what happened to those words over the course of treatment. And so here's what happened. These are 2 different participants. The x-axis is the session number, and the y-axis is words learned to a certain criterion value. And so these are like growth curves. And you can see the dark bars are the words that they reported successful inner speech. So they said, I can say that word in my head. And the blue bars are what we're calling unsuccessful inner speech. So they're telling us I can't say that word in my head. So that measurement was done at the very beginning, and then they just got the same treatment for both these sets of words. And what you can see is that they relearned the words that they said beforehand they had in their head faster, and they learned more of them by the end of the study. And this was significant even after controlling for things like word frequency. So it looks like potentially these things that people tell us about which words they have in their head and which words they don't have some clinical significance in terms of treatment outcomes. Okay, so back to the main research questions. Are reports of successful inner speech by people with aphasia meaningful, and what do they mean, and who experiences successful inner speech? So let's establish a hypothesis. So we're going to go back to this sort of generic model of naming that we pulled together from several different models. For the cognitive scientists, I don't want you to get too hung up on exactly what we've called these boxes and arrows. We can talk about that after the talk, because we wanted to start with pretty basic hypotheses. So we sort of dumbed this model down a little bit to make our hypotheses and distilled it down to 2 sort of main levels of processing. The first is lexical phonological access. So this is corresponding basically to the Dell model in the top box. And then the bottom is the speech output processing. So what's required to take those phonological representations and convert them to a speech motor plan. And the hypothesis is that when people say they have the word in their head, that they can hear the word in their head, what they mean is that they have successful phonological retrieval. So they've retrieved the phonological representation of the word. This was based on the Goodglass study, also based on just intuition of what's the least information that they could, what's the least they need to accomplish in order to get to that sense that they can hear the word in their head, and which levels at the time we thought were available to self-monitoring. So if this is successful inner speech, if this is what they mean by successful inner speech, then it means that if they have an incorrect naming attempt, then the problem must have been at the speech output processing levels. So in either something like sensory motor translation or in developing the motor plan. So that's the basic hypothesis. And this is the hypothesis we're going to test multiple times throughout the rest of the talk in a few different studies. So our general approach to testing this is we're going to ask people with aphasia about their experience of inner speech. We do that in two different ways. One with a questionnaire about inner speech during anomia in daily life, and then a couple of studies where we do silent picture naming and people report on a trial by trial basis whether they can name the words inside their head or not. And we're going to look for differences between people in how often they report successful inner speech. And then within individuals on these silent picture naming tasks, we're going to look at words that were reported as successful inner speech. So they say they can say it in their head, and compare those to words where they report that they can't say them in their heads. And we're going to look for differences in phonological retrieval ability, speech output ability, success of overt naming, types of errors that people produce, the word characteristics that tend to be associated with successful and unsuccessful inner speech. And sorry, gotta move this. And a little bit about their lesion location also in association with their inner speech. Oops. Okay. So I've got three studies to show you. The first one is one of Mackenzie's studies, which is using a questionnaire to assess inner speech. So we had 37 people who had been in a prior study in the lab, and we called them back to do this short inner speech questionnaire. This is a sample of anybody with chronic aphasia, any severity, any type. And in all of our studies, we try to exclude people with severe comprehension deficits because we're just concerned they're not going to understand what we're talking about when we ask them about inner speech. And here's the main question from the questionnaire that we were interested in. And we provide visual support like this for the question. We ask people if they can endorse the statement, I can't say the word out loud, but I can say the word in my head and it sounds right. So the question is, do you ever experience this? And if you do, how often? And we use just a 5-point scale from never to almost always for this. And then we contrast that with this experience of anomia. I can't say the word out loud, but I know what it is. And the picture support here is that they have the idea, but they can't get to the word. So the top question is the question about successful inner speech. And this comparison question, we needed to come up with a name for it. So we called it idea without word. And so these are two different subjective experiences of inner speech. And we also asked them about tip of the tongue, although we didn't provide support for that. So for each of these, they're endorsing whether it ever happens to them and giving us a rating from never to almost always about how often it happens when they can't say a word. Okay, and the basic hypothesis is that if they can't get to the word, the idea without word, we know that they weren't able to say the word out loud. So if they're endorsing idea without word a lot, that means that the problem must have been reasonably early in the lexical access processing stage because they feel like they didn't even get to the word. If they endorse tip of the tongue, they have some information about the word, but don't feel like they got to the phonology of the word. So we think that that should be down here. There's other hypotheses about tip of the tongue, but this is what we thought going in. And then successful inner speech means that they feel like they got to the word, but there's a problem in the speech output processing. So that's our basic hypothesis. So among the participants, about 80%, a little less than 80%, endorsed that they experienced successful inner speech at least some of the time. With a range of frequency values. And then we looked for the relationship between how often they say they have each of these experiences. And you can see that tip of the tongue was, the ratings that they gave for tip of the tongue were associated with both inner speech and idea without word, which maybe is consistent with it being sort of an intermediate level between these two. But that there was no relationship between how often they said they experienced successful inner speech versus idea without word. So the important point here is that just that they're able to discriminate between different experiences of anomia and give different ratings for the different experiences. And from a theoretical perspective, we think that the problems that should give rise to these two experiences, successful inner speech versus idea without word, should happen at different processing levels. And so maybe they shouldn't relate to each other. Now, there were some other behavioral results that I'm going to skip over for the sake of time. And I'm just going to jump to the lesion mapping results. So here we're going to look for lesions that are associated with these different experiences of inner speech. We're using a method called support vector regression lesion symptom mapping. And the question here is, where does a lesion relate to a certain experience of anomia, any of these three types? And so just to give you some hypotheses for this, we think that idea without word should represent a failure at the level of lexical access. And we think, based on speech processing models, that that should happen somewhere in the temporal lobe. Middle temporal gyrus was our best guess, but it could be superior temporal also. So if you have anomia and you failed to get to the word, the anomia should be arising from a lesion down here, we think. If you have anomia and the problem is that you get to the word, but you can't translate it into a motor program, then your lesion, we think, should be somewhere in the parietal lobe around supramarginal gyrus, and that should be associated with a feeling of successful inner speech. And if your problem is that you just have difficulty making the motor programs for articulation, then we think your lesion should be in the ventral premotor cortex or ventral sensory motor cortex more broadly. And again, we think that should be associated with a feeling of successful inner speech. Okay, so here's what the results showed. They correspond pretty well to our predictions. So red is people who experience idea without word a lot during their anomia, and their lesions were in the temporal lobe. The people who have anomia and experience a lot of successful inner speech, their lesions are in ventral sensory motor cortex, not so much the parietal lobe here. And then tip of the tongue, interestingly, was in the inferior frontal gyrus. We didn't really have a strong prediction about that, but that potentially is interesting. It's worth knowing this was a pilot study, a small sample size for lesion mapping. So these are all uncorrected results, but the pattern corresponded so nicely to our predictions that we were willing to interpret it. Okay, so the conclusions from this first study are that that feeling of successful inner speech is dissociable from other experiences of anomia. People with aphasia can discriminate between different experiences of anomia. And that the experience of successful inner speech is common. 80% of our participants endorsed it. And this is behavioral evidence that I didn't show you, may relate to post-lexical output processes. I'll show you more evidence for that later. And that the lesion locations associated with these experiences of anomia conform to our predicted anatomical patterns based on our hypotheses. Okay, so that's the first study. The next two studies that I'm going to tell you about use a different approach. Here we're using silent picture naming and self-reports of inner speech on each individual item. So we're asking people to name pictures inside their head and then say yes or no that I can say the correct word inside my head and it sounds right. We've done this in 3 different ways so far. The first study, we did inner speech judgments once after 3 sessions of overt naming. So that's the treatment response data that I showed you earlier. And we had some behavioral data from that also that I'm going to skip over. We've done it on 3 different days where they do the inner speech judgments immediately before naming each item aloud. We did that just in 5 people. And then Mackenzie's studies, we did the inner speech judgments once on a different day from the aloud naming, and that we did in 53 people. So I'm going to tell you about these second 2 studies. Okay, first the predictions. So we think that inner speech reports should be reasonably reliable from day to day. And if we compare successful inner speech trials to unsuccessful inner speech trials, so these are silent naming trials where people say they can get to the word and they can hear it in their head, versus trials where they say, no, I can't hear that word, I can't say that word inside my head. We think that when they say they have successful inner speech, they should produce more correct naming responses. When they make errors, they should be making phonological errors on those items that relate to issues with translation to a motor program. They should have more knowledge of the words in terms of knowledge of syllables and first letters. The words that they report successful inner speech for should be higher frequency and earlier age of acquisition items. These are attributes of words that are associated with lexical retrieval, but they shouldn't be items that are easier to pronounce. The ability to articulate a word shouldn't have anything to do with their inner speech if it relies on phonological retrieval. And then across people, the more often a person reports inner speech, the better their lexical phonological retrieval ability should be, but there shouldn't be a relationship between how often they report their inner speech and their speech production ability. Okay, so those are the basic predictions of the studies, the rest of the studies that I'm going to show you the rest of the way. Okay, first study, lots of inner speech reports in a few people. This is William's dissertation work. So here's what the task structure looked like for this study. We do 300 naming items. We have them do silent naming inside their head, and then they tell us yes or no, I was able to name that word inside my head correctly. Then we have them immediately name the word out loud, and then we ask them, did you get that word correct out loud? Now, I'm going to skip this for today. You can ask me about it at the end if you want. And we do the same 300 item and picture naming items on 3 different days to look for consistency across the days and to get a really good sample for errors and that sort of analysis. Okay, so here are the participants' lesions. We had 6 participants starting out. This one in the lower right only did 1 of the sessions, so we only have the 3 days on these 5. This guy had anomic aphasia, these 2 had conduction aphasia, and these 2 had Broca's aphasia. This one quite severe Broca's aphasia. Okay, so first thing we looked at was the consistency of their inner speech reports across days. And so the intuition here is that people should be reasonably consistent in terms of which words they say they can name in their head across the 3 days. They shouldn't be perfectly consistent because word retrieval is a probabilistic process, and we know people's ability to name words aloud varies across days, but they should be reasonably consistent, more consistent than chance for sure. So we code the items based on whether a person was perfectly consistent across the 3 days. So a given item like the word fish, did they say they could name that in their head on all 3 days? Or did they say, no, I can't name that in my head on all 3 days? And we compare that to sort of a binomial probability of how likely it is, given the amount of inner speech that a person reported, that they would happen to report the same item by chance on 3 different days the same way. And so we convert that to what we call consistency z-score. And on the left is the consistency z-score of the inner speech reports for all of the individuals, and then the group in black. And this dotted line is a p less than 0.05 versus chance. So what you can see is that all of the participants reported their inner speech more consistently than you would expect from chance, but we don't really know how consistent we should expect this to be. So to assess that, we compared it to their consistency in terms of their allowed naming accuracy. So just correct versus incorrect, which is the sort of same the same binary distinction as yes, I can name it in my head, or no, I can't. And what you can see is that in terms of their consistency of which items they can name correctly out loud, their consistency in which they say they can name inside their head is about equal. So across most of the participants, there was no difference in the consistency of inner speech judgments versus the consistency of their actual allowed accuracy. And I will say that going into this, I was actually really hoping that they would be more consistent in their inner speech reports than their allowed naming, because there are fewer, our hypothesis is that there are fewer processing stages that go into inner speech. And so there's sort of less noise accumulating in the system, and you might expect them to be more consistent in terms of their inner speech. But there's obviously some self-monitoring limitations here. And so just the fact that it was as consistent was sort of satisfying in terms of these being reasonably reliable judgments. Okay. The next prediction was that if a person says that they can't name a word inside their head, and then you ask them to name the word out loud, they should almost never name the word correctly out loud if they've just said, I can't get that word inside my head. So across all of our participants in all of our sessions, we had about 1,800 total trials where a person said, no, I can't name that picture inside my head. And of those, we had 10 correct naming trials afterwards. So that's very close to zero. It's not quite zero. But we thought this was reasonably consistent with the hypothesis. Now, in contrast, after people said that they were able to name the picture in their head, they got 64% of those correct when they named them aloud. Now, after we designed this study and ran all the subjects and looked at these data, we realized there's an issue here, which is that if you imagine yourself as a person doing this task and you've just pressed a button saying, no, I can't get that word in my head, how likely are you to try really hard to say it out loud? Probably not very likely. And if you just said, yeah, I can get that word in my head, you're probably likely to try really hard to get the word out loud. So to address that issue, what we did is we looked at inner speech versus aloud speech on different days. So here, what we're looking at is the proportion of items that are named correctly on one given day, depending on how often a person said they had correct inner speech for that item on the other days of testing. So if a person, so we're looking at, say, an item on session 1 in terms of their allowed naming and comparing that to how often they said they had successful inner speech for that same item on sessions 2 and 3. And what you can see is the more often a person says they have successful inner speech on the other days of testing, the more likely they are to get it correct on the third day of testing across all of our participants. This works, again, because word retrieval and production is a probabilistic process. And so the more likely you are to get a word on one day, the more likely you should be to get it on another day. Okay, so this conforms to the hypothesis as well. Now, when they don't name these words correctly, they should also be more likely to make a phonological error, especially a phonological non-word error, if they report a lot of inner speech, and that is the finding. So again, so phonological non-word errors are proportionate to how often a person says they have inner speech for a given item. This was also true of phonologically related real word errors. People had fewer no responses if they said they had more inner speech for an item, but there was no relationship between semantic errors and what they said about their inner speech. Okay, last thing that we looked at in this study is what kinds of words are likely to be reported as successful inner speech. And so again, the prediction here is that word characteristics that are related to retrieval but not production should be related to inner speech. So to do this, we had to control for aloud speech when we want to focus on inner speech. So what we do here is we look at all the trials where a person named the word incorrectly aloud. So we're only looking at incorrect naming, aloud naming trials. And then we divide those into those where the person reported successful inner speech versus unsuccessful inner speech. So this allows us to isolate inner speech from aloud speech. And what we find is that when a person reports that they have successful inner speech, on an incorrect aloud naming trial, that word has higher frequency and lower age of acquisition than words that they say they can't name inside their heads. Those words are not different, though, in terms of the number of phonemes, the number of syllables, or the articulatory complexity. So then to compare that to what goes into aloud speech, here We only look at the trials where a person says, yes, I can name that word inside my head. So we're only looking at successful inner speech trials. And then we compare words that they subsequently name correctly to those that they name incorrectly aloud. And a word that's named correctly after successful inner speech is higher frequency, lower age of acquisition, shorter in terms of phonemes and syllables, and lower articulatory complexity compared to words that they name incorrectly aloud. So this is consistent with the hypothesis that inner speech is relying primarily on phonological retrieval, sort of pre-articulatory processes, but overt speech requires both. Okay, so the conclusions here from study 2 are that inner speech reports are pretty reliable across multiple days of testing. That inner speech reports can relate to performance on naming performance on other days of testing. Successful inner speech reports relate to correct naming, to phonological errors when naming is incorrect, and to word features associated with lexical retrieval, but they don't relate to semantic errors or word features associated with speech production, like word length and articulatory complexity. Okay, so that is study 2. So we can move on to study 3. This is Mackenzie's work, which I've called Not Quite As Many Inner Speech Reports in Lots of People. That was not the title of either of the papers that Mackenzie published, though. Okay, so here, Mackenzie somehow got 53 people in the lab to do this project during her thesis work, which people at Georgetown still talk about that accomplishment. So all these people had adequate sentence level auditory comprehension. That was a score of 48 or greater on the WAB yes, no, in case you're curious. And here what we did is we did separate silent inner speech naming tasks and aloud naming tasks, but we used the same items for both of them. We had a set of 120 items. There were 60 items from the Philadelphia naming test and 60 items that we developed in-house to manipulate the word features that we cared about specifically. And these were administered in 2 sets across 2 different days. So they were doing different words for inner speech and aloud naming on each of the 2 days. And then we reused these same stimuli for other tasks to look at phonological retrieval on the same words. So let me tell you about those for a second. So the measures of phonological retrieval or lexical access were the same ones that the Good Glass study used: first letter identification and syllable counting. These were done on a subset of the words for which we had inner speech judgments and aloud naming, and we also did repetition on those words. And then we had a separate rhyme judgment task which used different stimuli. And each of these 3 tasks we did 2 different ways. We did using pictures, the same pictures that were used for the naming task. And then we had an auditory version where they actually did see the pictures again, but we gave them the word through headphones so they could do the judgment. And the reason we did this is because a person's performance, for instance, on syllable counting relies on making a phonological judgment. And we need to know whether a person is capable of making that judgment if we just give them the word. Or in the picture-based task, they have to retrieve the word themselves and then make the judgment. So we're going to compare the picture-based version versus the auditory-based version of these tasks to assess their phonological retrieval ability without worrying about problems with syllable counting or knowledge of first letters or rhymes. Okay. And then we had a battery of tests of speech output processing, which include word repetition on the same word, pseudo-word repetition, reading, again, pseudo-words and real words, and a motor speech evaluation. The first thing that we did with this was a within subject item level comparison. So this is sort of parallel to a Williams study that I told you about before. And the predictions here are that reports of successful inner speech for individual items will relate to word features that affect lexical access, but not features that affect speech production. So this is sort of a replication of what I showed you before. And that successful inner speech reports will relate to good performance on picture-based phonology tasks, But that inner speech shouldn't matter for the auditory-based phonology tasks. So that's just like a control. We're using generalized linear mixed effects models. And now for this within subject comparison, we really need people who report some successful inner speech on some trials and unsuccessful inner speech on other trials to do these within subject comparisons. And one thing that happened in this study is the cohort that we recruited was relatively mild, and about half of the cohort said on almost every trial that they were able to name the picture inside their head correctly. And so for these within subject tests, we're only using 27 of our participants, and then we'll come back to the rest of the sample and talk about them afterwards. Okay, so first question was about word features that affect, that are related to inner speech. And these results pretty much replicate the results that I showed you before. So inner speech reports so people were more likely to report successful inner speech on higher frequency words and words with lower age of acquisition, but articulatory complexity had nothing to do with their inner speech reports. And if we compare that to words that they name correctly or incorrectly aloud, all three features matter for spoken naming. So again, this is consistent with inner speech reports relying on pre-articulatory sort of phonology. Okay, the next question is about the phonological judgment tasks. So again, the prediction is that when a person says they have successful inner speech for an item, they should know more about that item than if they say they have unsuccessful inner speech on an item in the picture-based tasks, but not the auditory-based tasks. So here's the results for the picture-based tasks. We have spoken naming, first letter judgment, and syllable counting, all using the same pictures that they judge their inner speech on. And in dark blue are the trials where they report successful inner speech, and in gray are the trials where they report unsuccessful inner speech. And there's a big difference in performance across the group between those two trials, where they're able to do the phonological judgments when they say they can get the word in their head, and they have more difficulty with the judgments when they say they can't get the word in their head. And here's their performance on the auditory version of these tasks, where we give them the word, so it shouldn't matter if they have inner speech or not on the word, and it doesn't. So whether or not they reported inner speech doesn't matter for the auditory judgments, which is what you would predict. Now, one other thing that I want to point out here is that if you compare the blue bars over here, so their performance on first letter judgment and syllable counting on words they say they can get in their head, to their performance on the auditory version of the task where we give them the word, there's really a very small difference between their performance. So when they say they get the word in their head, it seems like they get the word in their head, and they do just as well as when you just give them the word auditorily. Okay, so how are we doing on time? Okay, so now we had that half of the group that reported inner speech on almost every trial, and that raises some questions about the reliability of these reports. So let's back up and talk about that for a minute. Okay, so 26 people were excluded because they reported inner speech on almost every trial. But it turns out that when we look across those people as a group, they do much better on spoken naming than the other participants. So they, on average, reported 32 more items than the group that were included in that within subject analysis for inner speech, and they actually named 35 more items correctly as a group. They also do better on the picture-based first letter and syllable counting than the rest of the group, but they don't do better on other tasks like repetition or the auditory judgments or comprehension or speech production measures. So we can't say much about the individual participants. There probably are individuals that are unreliable in this group, but as a whole, they're performing like they have inner speech on almost every trial. So they, as a group, I would say they're not necessarily being unreliable by reporting so much inner speech here. It may just be that they have mild anomia. Okay, so there was some evidence of unreliability though. So we looked at the performance on the 2 days of testing. They're doing different items on the 2 days, so we can't do an item level comparison of reliability, but we can look at overall how much inner speech they reported on the 2 different days. And the intuition is that these are matched lists, and so they should report roughly the same amount of inner speech on the 2 different days. And they do. We compare that to the number of items that they name correctly on the 2 different days. This is a histogram where on the x-axis is the difference in performance. In this case, the number of items they report having successful inner speech. In this case, the number of correct items in the naming task. So this is the difference in performance across the 2 days. We would expect people that are performing consistently should have a low value on this. And you can see that most of the group, their consistency on inner speech reports is very similar to their consistency on spoken naming. But we did have these three participants who reported their inner speech wildly differently on the 2 different days. So 30 to 40 items different on the 2 different days. So there were 3 of those who were inconsistent in terms of their inner speech reports. And then we looked at performance on those picture-based phonology tasks to see among the 27 people where we could do the comparison, were there people who reliably didn't seem to have more phonological information about the words that they reported being able to name inside their head? And there were 3 of them. So that's actually pretty good news. 24 out of the 27 showed consistently better performance on successful inner speech versus unsuccessful inner speech items. But there were 3 who didn't. So maybe these 3 are unreliable. Now these 3 people were different than these 3 people. So altogether, we had 6 participants where it seemed like there was reasonable evidence that they were not reliably reporting their inner speech. And when we compared those 6 to the rest of the group, those 6 were more severe. They had more severe aphasia overall. They had lower comprehension scores. And then something I haven't mentioned before is that we also look at spontaneous error detection in our Aloud naming. So this is when a person gives an incorrect response, but then says, oh no, that's not right, or they try to self-correct. And these people did that less often. So it seems like they're doing a little bit less error monitoring than the group as a whole. Okay. So those are all the within subject questions from this study. And then the next question was, well, who is it that reports a lot of inner speech? And the prediction here is that people who report a lot of successful inner speech should have pretty good lexical phonological retrieval ability, and that there's no relationship between how often a person reports successful inner speech and their speech output processing ability. So these are the same participants, the same tasks as before, but this time we're doing sort of a group analysis looking for differences between people. And what we did here is we took scores of speech output processing, including pseudo-word reading and repetition, and some elements of the motor speech exam, as well as measures that we thought best reflected phonological retrieval. So this is a difference in performance between the picture-based and the auditory versions of our phonology tasks, using a sort of subtractive logic that the picture-based tasks rely on word retrieval plus whatever the phonological judgment is, whereas the auditory tasks rely primarily on the judgment. And so the difference should reasonably isolate word retrieval ability. So these are all the measures that we're going to use. And we distilled these down by using a principal components factor analysis. And that factor analysis confirmed that we had isolated 2 principal components here, one that loaded onto all of our speech production tasks and a little bit onto the rhyme judgment score, and the other that isolated and grouped together our phonological retrieval measures. So now we've got just 2 scores to work with, one that measures, we think, speech output processing, and one that measures lexical phonological retrieval. And we're going to look for relationships between this and their inner speech reports. And so the prediction is that we think that spoken naming performance should relate to both factors, to phonological retrieval and to output processing, but that inner speech reports should only relate to their phonological retrieval ability. And so here's the spoken naming. These are just correlations between their spoken naming accuracy and their factor score on these two factors. And we do find that both factor scores relate to their spoken naming ability. But when we look at just how many items they report having successful inner speech for, what we find is that that relates only to their lexical, their phonological retrieval score, but not to their speech production output processing score. So that again is consistent with the hypothesis. Then just for fun, we threw these measures into a hierarchical regression trying to predict spoken naming. So the first step, we put in our two factor scores, the retrieval factor and the output speech output factor. So based on our model, both of these should contribute to naming accuracy, and they do. So both are significant predictors in this model with a pretty decent adjusted R squared. And then the next level, we added in our inner speech report. So this is, again, how often they report having successful inner speech. So we add that into the model and at this point use a backward elimination strategy. And what we find is that adding the inner speech reports improves the model fit. So our R squared, or adjusted R squared, goes up by about 12 points. And interestingly, the inner speech report kicks out the retrieval factor from this regression. So now we just have inner speech reports and the speech output processing factor being significant in this model. So in this kind of analysis, you could say that the inner speech reports were more strongly related to spoken naming than our objective measure of phonological retrieval. Okay, last question was about lesion location for this analysis. Now you'll see the N here is up to 73. So we had 53 subjects from Mackenzie's work. Not all of them had imaging. So we had about 40, low 40s to work with from Mackenzie's work. That's not quite enough for a really good, well-powered lesion symptom mapping analysis. So we've continued to collect inner speech judgments on a smaller number of items in our current study, along with all of our other measures. So now we have an N that's up to 73 for these analyses. And I want you to focus on how pretty this lesion overlap map is and how beautiful the colors are, because there is no result from this analysis. So no lesions that relate to how often a person reports successful inner speech. And if there were a trend, I would show you the trend, but there is no trend in this result. There's just nothing. Now, that's not shocking to me because we think this is related to phonological retrieval, which is maybe distributed and maybe not localized to a given location. What I was more optimistic about was an analysis where we looked at the difference between naming and successful inner speech. So we think that the difference between allowed naming accuracy and how often a person reports successful inner speech should do a pretty good job of isolating areas involved in speech production in the dorsal stream, so either parietal or ventral premotor. And I should say, I didn't put this in the slide deck because I was worried about time, but I did run an analysis looking at the speech output factor from the factor analysis, and that beautifully localizes to the areas you'd expect in a ventral premotor sensory motor cortex. But this analysis also yielded a null result. So no lesions that are associated with a discrepancy between allowed naming and successful inner speech. And again, not really even a trend to tell you about. So this is kind of disappointing and surprising to me, and I'm happy to talk about it more. We have developed in the lab methods for connectome-based analyses that seem to be a little bit more sensitive, especially when processes are more distributed. And we haven't gotten around to looking at these data with that method yet. And so maybe something will show up when we do that. Okay, right. And so I think it's the curse of the scary picture that's hanging above my bed that led to these null results. I forgot I put this in 5 minutes before the talk. I forgot I did that. Okay, so the answer, who reports a lot of successful inner speech? So people seem to report successful inner speech in relation to their lexical phonological retrieval ability, and their speech output processing ability supports spoken naming, but doesn't seem to have anything to do with how often they report successful inner speech. And in this study, these inner speech reports explain more variance in spoken naming than our objective measures of retrieval. I don't know if that says more about the inner speech reports, or maybe we're not using the best measures of retrieval, but still it's useful to know. Okay, so the overall conclusions from these studies. So lots of people with aphasia can make meaningful judgments about their inner speech. A lot of people experience successful inner speech. And when they say things like, I can say it in my head, what they seem to mean is that they're able to retrieve the phonology of the word inside their head. And they're not talking about some kind of internal articulatory or speech output plan when they say, I can say it in my head. At least most of them aren't. When they have a failure of spoken naming and a sense of successful inner speech, that seems to reflect deficits in post-lexical output processing, so the motor planning or the translation to the motor plan. And so this means, we think from a cognitive perspective, that inner speech doesn't require these speech output processes. So it doesn't require internal modeling of articulation in order to have a sense that you can say a word inside your head. I don't think that would be surprising to many people who study inner speech, but it's still good to document in, I think, a Bayesian context. All right, and that is what I had to show you today. So I'd like to especially thank Mackenzie, who's here with us, along with William, and the two other main collaborators on this work are Sarah Snyder and Rhonda Friedman. And then I'll thank the rest of my lab too. And thank you all for listening, assuming you're still listening, I can't tell. And thanks for inviting me.
Thank you very much, Peter. That was fascinating. A lot of beautiful work to both you, Mackenzie, and all your other collaborators. I'd like to start off with a question, if you don't mind, and then maybe open it up. So, I think that the question of whether inner speech is a simulation of a prediction. Simulation and predictive processing have been aligned in many accounts, right? And so the question is whether you think it's more akin to a prediction of, if I were to produce this sound, forget about articulatory details right now, but if I were to produce this is what I would expect to get back. So, or is it more like, this is what I think it should sound like in a more abstract sense, but has nothing to do with my planning system? Because you align planning with a relatively late phase, sort of the details of articulatory planning. But of course, planning happens at every, this sort of forward prediction happens at every stage. So what are your thoughts? And do you have any thoughts about how you would disambiguate those possibilities?
Yeah, I mean,
go ahead.
No, I think that's a great question. I think, we're working, and I alluded to this at the beginning, with a sort of, a pretty basic model of naming and speech production as a starting point, because I think we're relying on people's self-reports, and it's not, we lumped together things like, I can hear it in my head and I can say it in my head. And so we're not asking a very nuanced question here. We're sort of validating a clinical phenomenon, really. Okay, so I think the answer, my answer probably is that it depends on the exact context. And so these are people who are trying to produce a word out loud and can't, but they can think of the word in their head. And that's different than when when sort of neurotypical people exercise in inner speech. They are volitionally not producing the word out loud. And you can say, in our silent naming tasks, that's also the case, where we're telling them not to produce the word out loud. And so I think that is going to matter potentially for what exactly is going on. So, and how that happens, so what the difference is in planning for silent speech versus planning for a loud speech, I think there is some research on that. I know there's some suggestions that silent speech requires inhibiting the actual articulatory act, for instance. So, is it a simulation? Is it a sort of a model of the planned articulation or the expected consequence of the articulation. I think it very well might be. I'm trying to think if our data are consistent with that. It could be from an earlier stage if there's an internal sort of feedback loop. I don't know. How would you get at that? I don't have.
I was just thinking about, I don't know you language folks, but are there tasks that are purely comprehension, input oriented, where people would have to distinguish phonological errors or something? Would you have any differential predictions about the correlation of inner speech with processing purely on the input side versus on a task where you might implicitly, but even on those input tasks, you might be implicitly planning outputs. It's very hard to suppress that, isn't it?
Yeah, I think it is. I mean, also keep in mind that because these are, in this case, we're talking about subjective judgment, so we could move away from that to doing sort of more objective measures. In the case of these subjective judgments, we're also relying on people's error monitoring ability, which we know varies from person to person, and we've done some work on that now as well. And so I think it would be difficult to isolate, but maybe using more objective measures. I also think
about.
Yeah, I think there's also room for more physiological data. We had tried doing imaging early on, where we would scan people during silent naming inside the scanner, and we had already assessed their ability to name items aloud outside the scanner, and then had them doing these interspeech judgments inside the scanner to look for differences.
So people with pure word deafness, can they do interspeech?
I would expect so.
You would too, but yeah.
Yeah, would you think not? I'm not sure.
No, I don't know. I was just trying to think of a disorder in which the deficit is on sort of much more on the input side without any accompanying planning deficit.
Yeah. So can I ask why? I'm not. Maybe I'm not.
I don't know. Maybe I don't know. I was just. I don't want to hog things either. So I see John has a question.
Yeah, thanks. Very, very nice talk, Peter. Sorry, I can't show myself. I wanted to ask, you might have mentioned this along the way, and if so, I missed it, but do we know how accurately folks are at predicting their out loud naming?
Yeah.
Are they very accurate or not?
That's a great question. So we have just, we're probably going to submit a study on that later this week. So I can show you one slide if I can find it. Actually, I don't have the behavior on this slide, but so in one of our questionnaires, we asked people how often they're able to say a word correctly out loud, and then we are comparing. So we look at that at 2 different days to assess their reliability on that judgment, and then we compare that to their actual naming performance, which is maybe not a perfect task for the comparison, but that's what we do. And we're using sort of arbitrary cutoffs for how we judge whether a person can accurately name, but the 2 are very strongly correlated. So people can guess pretty well their naming performance, or when they say how often can you name a word, or can you say a word correctly, they pretty well approximate their naming scores overall. But there are people who either give different responses on different days or are poor estimators of their naming ability. Those people tend to have frontal lesions, which is what I'm showing here. And the people who are good estimators of their naming ability tend to have posterior lesions.
And I'm sorry, when you're talking about good estimators and poor estimators, you're not talking about word by word. You're
Right.
talking about in general, I can name a lot of words, or in general, I can't.
Right. So we have we haven't done it word by word. One of the things that we have wondered about. Oh, actually, I do have something to say about this.
Well, and let me just tell you why the reason that I was asking this, because that might affect your response, which is that, I mean, you get out of this in a couple of your methodologic moves, but when you ask someone in a task where they're first gonna say, can I covertly name it, and then they're gonna have to name it, I guess my question is, are they really answering two separate questions, or they have already retrieved and are prepared to articulate the name? And of course, that means they had an internal model as well, and they already, so they sort of answer the second one and use it for the first one, if you will. So that only the ones where a person says, yes, I can internally name it, but then cannot truly give you independent information about, what their internal processing is. Do you get what I'm saying?
I think I get what you're saying. So, and let me answer that by giving you a little bit more information that I didn't show. So, okay, so one of our concerns, which I think is the concern you're getting at, is that when people are giving their judgment of inner speech in that, specifically in that context where they're about to name the word out loud, that what they're actually telling us is, yes, I think I can name this word correctly out loud, or no, I don't think I can name this word correctly out loud. Is that what you're?
Kind of, yeah. And that the way, well, moreover, that the way they're answering that is that they have the subjective sense of having prepared the motor program, which is the reason that I asked whether people can accurately predict whether I will be able in a moment now to say this word yes or no, because that's sort of saying I do or don't have the motor program available.
Right. Well, I think, it's not great evidence, but I think the fact that the articulatory complexity and the length of those words doesn't predict their successful inner speech response, their inner speech response probably speaks against that.
Yeah.
But it's not, it's just one piece of evidence. I think you would want more. But I will say that I do think there's a real concern about the task that they're doing affecting their judgment.
Yeah.
And that's why in the next study, we broke them up and we did the inner speech and the aloud speech separately.
Yeah.
And the specific, I have some evidence that this is true, which is that what I didn't tell you about is in Williams' study, we did a separate set of tasks. We did, I think it was first, this is a long time ago now, but I think it was the first letter and syllable counting again, if I remember correctly. But what we had them do is we had them do that paired with the inner speech. So they would do their inner speech judgment, and then they would do syllable counting and first letter judgment instead of naming. Okay, so this was a separate set of tests. And what we found was that the tasks that they performed after the inner speech judgment affected their inner speech judgments. And so that they gave different, their responses to the inner speech judgments were different when they were about to do first letter judgment or syllable counting compared to when they were about to do naming. The responses were very consistent, like I showed you, as long as they were doing naming after the inner speech judgment. But when they were doing a different task immediately after inner speech judgment, then they gave very different responses to the inner speech. So I had actually kind of forgotten about that. So I'm glad you asked this question. So we do think that now I don't know whether that's a planning, whether it's because they're answering the question, do I think I can do the next task that I have to do, or whether it's something about, like you were saying, the sort of influence of what they're about to do sort of percolating back, and it's sort of like a predictive model, or it may be something completely different. But that does matter. The task context does matter for these judgments. Yeah.
Thanks.
But we have a couple of other questions. Sorry to interrupt. Tatiana and then Abby.
Hey, Peter, I really enjoyed your talk. I was puzzling over the not even a trend in the LSM results with 73 people. That just seems disappointing, as I'm sure you've been experiencing for a while now. So as I was thinking about it, you said, well, it's clear, these people are in this tip of the tongue state. We're in this post-lexical output processing, that there's some deficit there, right? And you have 73 people who likely have deficits at some potentially different part of that processing stream. And you have information about what part of that processing stream they might have problems with, because you've collected, like, can they do the regular tip of the tongue, the first letter and syllable and other stuff like that. So I was wondering, like you said, oh yeah, there are no results to see, because I've clustered a bunch of people who I think are doing this task the same way, but in fact have deficits in different places. So
yeah,
the outcome variable is not capturing that. So have you try to explore that idea by making the group sizes smaller, but they're more consistent?
Yeah, that's a great idea, actually. No, I haven't done that. We didn't do that when we had just Mackenzie's data either, as far as I recall. We have done, the lesion symptom mapping on a couple of, so like on pseudo word repetition versus some of our apraxia measures, and they do localize to different locations. They're not so far apart, parietal versus ventral sensory motor, but they are different. So that's a good idea. We can easily break those people apart, I think, to some degree, or add as a covariate or something like that to address that. That's a really good idea. Thank you.
Good luck.
Thank you.
On that point, it also seems like you could regress out from your behavioral measure of the inner speech score, regress out other components.
Yeah.
So that because maybe people have deficits sort of on both levels. So you'd want to be able to pull out what is just the inner speech as said, like a compounding.
So what are you thinking of, Denise?
Well, I guess off the top of my head, maybe regressing out the, I guess it would have to be would be the retrieval factor. Like, so if there's some people who are, like showing evidence of having retrieval issues plus the, output issue, and then others who are clearly more on the output side and clearly more on the retrieval side, that, you might just be getting more of a muddled sort of looking at lesion that could partially overlap with those two things.
Right. Yeah, that's a good idea. Thank you.
Okay, I want to make sure we have time. We have Abhi and then Erica.
It's a great talk. Thanks for the talk. So I was just wondering, would you expect, say, on items that they have successful inner speech and produce an error, would you expect a larger error-related negativity on that? Like if we do EEG?
It's a good question.
Yeah, you might. Yeah, I think you probably would, right? Because at least the way that we've done this, if you're having them do the inner speech before I think you probably would. In either context, maybe, if they feel like they can say it in their head, but then they can't say it out loud. Certainly in the context where you have them do the inner speech and then name it out loud, you would expect that. That's a great idea. What I'm trying to puzzle through is, the sequence of events when a person experiences this sort of just generically, if they, because the generic report is they can't say the word out loud and they feel like they can say it in their head. But what's not clear to me is when they mean they feel like they can say it in their head. When you and I speak out loud, we don't feel like we're hearing it in our head as we're speaking it out loud. We just say it out loud and it comes out. I don't have a feeling that I'm saying words in my head right before they come out of my mouth. And so it would be nice to ask them what that experience is like. But yeah, certainly in the test context that we're using, I think that's a great idea. Yeah.
Thank you.
Mm-hmm.
So, yeah, Peter, I've always really just love this line of work. So I love it to see how it's progressed. And I'm really interested in how inner speech might relate to incremental learning. So I love the finding that it relates to kind of the trainability of individual words. But I was wondering, and you might even be able to do an analysis like this, but the notion that in incremental learning models, it's error-driven learning. If you have the target, that's kind of a signal that can drive learning. Inner speech might actually be a target, like an internal target that could drive learning. So I was wondering if you could get an index of learning by looking at if they do inner speech and then later naming versus earlier naming and then inner speech, so that you have an index not only of general relationship of inner speech to the strength of an item, but the rate of change at a later time.
Yeah, that's a really interesting idea. So are you, Erica, if I'm understanding, you're in the context of the data that we have right now, this would be in William's study where we did the 3 different sessions. And so you'd look at, for instance, whether the inner speech, when I showed, for instance, that inner speech relates to naming on different days, the prediction would be that
is that if it's successful inner speech versus unsuccessful inner speech, the index should be great. It should be higher, more highly related to future performance.
Right.
And the baseline, because successful inner speech is going to be more highly related either direction, but that's the kind of baseline. And then in addition to that, future performance should be even more enhanced.
Yeah. I think that's a great question.
Because we use that index in the Schwartz et al. 2016.
Yeah, I remember. Maybe we've had this conversation before because this feels familiar to me, or maybe I'm just thinking of your work where you did something like this. But that's a great idea.
And it also kind of would provide additional evidence for the functional relevance of the subjective experience. So it's interesting.
Yeah, that's a great idea.
I want to call on Dylan, but I just wanted to, because this what I was asking earlier about whether Peter thinks this is an auditory representation of what a word should sound like, or a prediction of what the word would sound like if I were to produce it. And I was wondering, Erica, if you think both of those might serve as targets for learning. When you say target.
Well, I mean, in incremental learning models, like you have an activation vector when you're retrieving a word, and then something is selected, and that's the target vector. And it's the difference between those, the computation, the error-driven learning, that drives the changes in the weights. So whatever that, those two vectors, I mean, it's still, I think, in the first stage of naming, it's been implemented formally. But I don't know how to think, like to take that and put it onto your notions of representation. But.
Right. Okay. Dylan, you had a question.
Thank you, Peter. That was really wonderful. I appreciate it. My question's fairly simple, I think. I'm trying to get my head around what happens under normal circumstances. I think you just mentioned it, that we don't, when we're naming and we perhaps come up with something that's a bit more complicated, we don't have inner speech. I think I heard you just say that a second ago, or it's not common in a normal naming and speech production. So I'm wondering the extent to which inner speech is kind of a pathological compensatory sort of mechanism. And if I understood correctly from this talk, having this inner speech is useful. Giving the word auditorily can also have a benefit in the person producing the word. I'm thinking from a therapeutic perspective, like where might this go therapeutically? Do you imagine that a therapist might try and promote inner speech, actually by not saying the word, by pushing them to, or do strategies to promote inner speech? Or is it I'm trying to get my head around the extent to which it's compensatory or helpful.
Yeah, no, it's an interesting question. So I would say it's not the case, I think, that we don't have inner speech or that inner speech is sort of a pathological compensation. I think usually what I meant when I said when we speak aloud, we don't have inner speech. So the way I think about inner speech is that it's, and not everyone agrees with this, but that it is the processes that lead to aloud speech. And when you subjectively experience inner speech, you're just evoking sort of a monitoring mechanism to keep an eye on that processing. And then when we speak aloud, we're probably suppressing that monitoring, so at least consciously, so that you're not consciously aware of what you're about to say right before you say it. This may not be exactly precisely right, but the idea is that when you're speaking aloud, you're sort of suppressing your conscious awareness of the stages of processing leading up to it. So that so for us, we can suppress our aloud speech and bring the sort of processes to, or the imagery, if you want to put it that way, volitionally to a level of self-consciousness. I don't know if that's exactly right, but that's sort of the way to think about it. Mm-hmm. It's this discrepancy between the aloud production and what the person expected to say that sort of brings it to conscious awareness in a person with aphasia, I think. Yeah, but we can evoke that conscious awareness volitionally without having aphasia by keeping our mouth closed and thinking inside our heads. So in terms of the treatment implications, Mackenzie and I are going to have a talk about this, I think, next week, because I'm hoping that she's going to do some treatment studies related to this. We've focused mostly, and I would love any of your input on this, but we've focused mostly on these sort of hypotheses about using inner speech to get a sense of where the sort of level of processing failure is, either across people or with individual items, so that you can select the most appropriate treatment for people or for individual items. Or possibly from that first finding where when a person reports successful inner speech, they learn items more quickly, that may be a way to prioritize words, that you can get a lot of bang for your buck by training words up that a person already reports inner speech for that are important for them, something along those lines. So that's what we've talked about with the potential treatment implications so far. I think it's really interesting, this idea that that the inner speech could serve as a target for learning, and that we want to give that some more thought as well, and maybe talk to you more about that, Erica, because that's a really interesting idea too, with important treatment implications, I think.
Maybe one last question, Denise.
Yeah, so I was just curious, at the very beginning where you showed the 2 participants where you first started looking at this, did you look to see whether successful inner speech actually increased for those unsuccessful inner speech items after the treatment?
No.
So I guess that could also kind of get at how this relates in a clinical setting.
Yeah, no, we didn't. We only, in that study, we only assessed inner speech before the treatment. Now, the intuition would have to be that if they can name the word correctly out loud, I sure hope that they would say they have successful inner speech for those words after training. But we didn't look at that, and we didn't look at the items that they failed to learn, whether they gained inner speech on some of those items.
Yeah, or even maybe looking like long-term after the treatment to see if, any items maintained that weren't successful inner speech before treatment maintained some level of successful inner speech after, long after, because that could be potentially a predictor of how well the treatment would sort of maintain.
Right. Yeah, that's an interesting idea. We didn't look at it, and we haven't repeated that experiment again, mostly just because it was sort of an opportunity at the time that Rhonda was about to do this treatment with these people, and we just had this idea. And we don't do a lot of behavioral treatment like that in my lab. So, and Rhonda's now doing other work. So, we've also thought about looking at this in PPA and other contexts as well, but we haven't done that either.
Cool. All right. Well, it's a little bit after 5. I think we should probably stop. Of course, people can stay around if they wanted to a little longer. Haley, I was going to ask if you wouldn't mind staying for 1 second. we can chat with Peter a little bit. Hopefully, if Peter has 1 more minute.
Yeah,
I know you're on.
I have time. Okay. I've been eager to meet.
All right, and anyone else who wants to. But thank you so much. This has been wonderful, and thank you for all your great questions, Peter. That was really thought-provoking.
Thank you. Well, thanks so much for having me again.
All right. Yeah. Take care, everybody. See you again soon.